Hi everybody, today we're going to talk about Lesson 91, Simplifying Decimal Numbers. Before we get started though, I want to do a quick review of the distributive property way back in Lesson 40. Okay, so the distributive property is shown here on the screen, and it says that A times the sum of B plus C is equal to A times B plus A times C. So what that means in numbers looks something like this. 8 times the sum of 2 plus 3 is equal to the product of 8 times 2 plus the product of 8 times 3. So just for fun, let's go ahead and solve this, and let's actually do this using our order of operations. So I know, because of order of operations, that I have to do what's in parentheses first. And I know that 2 plus 3 is 5. So this would be 8 times 5 is equal to, parentheses again, 8 times 2 is 16, plus 8 times 3 is 24. Okay, going back to my next step, 8 times 5 is 40, and 16 plus 24 is also 40. So this shows that whether I add the addends and then multiply the sum, or I multiply each addend separately and then add the products, I still get the same number. Why is this important? You will need this in example 3. So let's move on to there and get rid of this. And we want this. Come back. All right, so lesson 91, simplifying decimals. Just like we simplify a fraction, we can simplify a decimal. Simplifying a decimal means getting rid of extra zeros. Okay, so what do I mean by an extra zero? Let's look at this problem. Otis had added 3.75 and 2.75, and he found that the sum was 6.50. Well, we know that 0.50 in a fraction means 50/100ths. I know that I can reduce 50/100ths to 5/10. And I know that 5/10 in a decimal means 0.5. So I can actually take this 6.50 and simplify it to 6.5. And I can get rid of this 0 right here. Because there are no digits to greater than 0 to the right, I don't need that 0. It's telling me I have 50/100ths, which we know is the same as 5/10. So I can reduce 6.50 down to 6.5. Okay, let's look at another example really fast. Okay, if I take this number, 5, and I want to add a 0 without changing the value of the number, I cannot just add a 0 here, because now what number do I have? I have 50. Well, that's changing the value. But if I put the decimal here to make it 5.0, I have not changed the value of the 5 at all. I just have an extra 0 here in the tenths place. It's telling me I don't have any tenths, but it is adding a 0 to the end of the number with the decimal point does not change the value. Okay, I can also do that backwards. If I had 7.00 and I wanted to simplify this, I can get rid of the decimal and both zeros and just leave the whole number 7. It works both ways. I can add a decimal point and add zeros without changing the value, and I can take away the decimal point and the zeros without changing the value, as long as there are no digits. If this number was 7.01. I could not simplify this and take out this 0 because this tells me that I have 7 and 1/100ths. If I got rid of that 0, it would suddenly look like 7 and 1/10, and those are not the same numbers. So if there is a digit greater than 0 to the right of a 0, you cannot get rid of it. Okay? All right, let's look at example 3 and look at how the distributive property plays into today's lesson. Okay, in a classroom experiment, a snail moved at a rate of 1.2 centimeters per second. Okay, not very fast. The experiment was repeated and the snail again moved at a rate of 1.2 centimeters per second. Write an expression to represent the total distance that the snail moved during the 2 experiments. Now you're going, Mrs. Pendry, it didn't tell us how long they moved or how far they moved. So we're going to use some variables. We're going to use F for the first experiment, and we will use S for the second experiment. So I know that for the first, the snail moved 1.20 centimeters times F. F is the amount of time, okay? These both represent time that they moved. So how fast they moved times their time, put these in parentheses, plus 1.20 seconds again, or 1.20 centimeters, times S, the amount of time they moved for the second time. And this will equal the total distance. Now, I can simplify this using the distributive property. I see 1.2 centimeters here and 1.2 centimeters here. So I can actually use the distributive property in reverse. 1.2 centimeters times F plus S, and this will also give me the total. Okay, so refer back to this. I can also take this and reduce 1.20 even further to 1.2 centimeters times F plus S. All right, that's it. Off to your lesson practice. I'll see you tomorrow.